limitation that we had previously. So Matter actually looking to solve that, so that so it's like a common language, like how we have English now, so that multiple nations, multiple citizens, set of people can talk using the same language. That way, a light can talk to the say motion sensor, okay, directly. So the motion sensor says there is motion detected. Can you switch on the light? The light is able to switch on, rather than hoping that light and the motion sensor are HomeKit enabled and they talk to Apple device and things like that. Okay, similar case with Bluetooth. And Thread is also a communication technology, which is again, it's new and IoT focused. And so they have very big brands behind them, and they are developing that protocol such that again, similar to Matter, we are able to connect any device to any other device and get them to communicate without much trouble. And then there are other, as of now, they have, so the Thread and Matter are upcoming protocols for IoT, but Zigbee, Z-Wave, and LoRa have been popular in the uh, previous decade. Okay, wherever IoT was, so Zigbee and Z-Wave and LoRa also, for that matter, are very long range protocol. So they are able to talk over not just Bluetooth range. So Bluetooth can talk only up to 15 feet or so. So Zigbee, Z-Wave, LoRa are able to talk much farther. So that way you can, so in our smart agriculture example, you have acres of farm. So you can have sensors in multiple corners, and they can all directly talk to your gateway sitting at your home or whatever the gateway point you have, center of the farm or something like that. So they can directly communicate over Zigbee or Z-Wave or LoRa. Or if you have very huge expanses, or you have think there is no central gateway as such, you can use technologies similar to 5G, where it directly talks to the satellite or the cell tower that is nearby, and that way it gets connected to internet and we are able to get the data. So these are wireless protocols that we are talking about up till now. And there is one set of wired protocols as well. So in an industrial setting, let's say we have 20, 30 machines that need to talk to each other to perform some action. So only you want the bottle sealing machine to start only when the bottle filling machine has completed. So these kind of communication happen over either the serial interface or interfaces like CAN bus. So CAN buses are usually used in uh, vehicles. So whenever you are trying to build your own vehicle, smart vehicles, CAN protocol is the primary one used. So it's again a single wire communication protocol. Ethernet is four wire communication protocol. Serial is a two wire protocol, and then you have some other short range protocols called SPI, I2C, and I3C. Okay, so these are all for individual sensors to talk to individual controllers in a very small scale setting. Okay, say you have a controller here, and within few feet you have sensors. So that gets connected using serial or SPI or technologies like that. And then over feet and meters of distance, generally people go for wireless or Ethernet. Okay, so this was so these are some communication technologies. So in case any of you have doubt, please unmute and ask, or you can put it up in the chat box. Okay, Adya certificate, I am not very sure currently. Okay, so maybe when one of the other Yantra members join, the team members, I can ask them. Okay. Yeah. So we'll continue. Okay. So after communication, we just wanted to give a brief of how actually to go about the prototyping, how actually to build stuff. So usually when it comes to electronic circuit, there are two primary ways to connect them. So you can either do a form of welding, which in the electronic world it's called soldering, or there is a component or a thing called breadboard, which is basically plug and play. It is similar to how you have. I just quickly, yeah, the browser. So we have. So similar to how you have extension boards for our to connect one multiple devices, multiple, let's say multiple phone chargers to the same outlet. So similar internal, there is a thing called a breadboard that allows to connect tiny pin uh, uh, connectors with each other to complete circuits. Okay, so I can just show a quick demo. So we are on a tool called Tinkercad. So we'll come back to this later, but I'll just quickly show it to see how it works. So we have a breadboard here, and here you can see as I click on, as I hover around one of the pin, it shows me what other pins it is getting connected to. So this entire row of pins are connected together. So whatever, if I put a wire from here and say I have pulled out a wire, so this entire row of pins get connected to that wire. Okay, so that is how it works. So I'll just quickly show you one simple circuit. So we have an LED. LED is light emitting diode. It basically, when you pass current, it switches on and emits light. We have a resistor to limit the current. Okay, and then I'll put a battery. Okay, so in the top and bottom row, you can see it is called power rails. The entire left to right row is connected. Okay, and in the center, these are where you connect your other circuit, where only these five pin sets are connected. Okay, so I will take one of the pin from positive of the battery and connect it to the anode of the LED, and take negative of the cathode of the resistor, connect it to the negative of the battery, and then say start simulation. So you'll see the LED has turned on. So stop and start. You're able to see the LED turn on and off. So that is basically how a breadboard works. So so just as simple as I have done it on the screen, similar. It is basically the same difficulty in real life also. Okay, so you just push pins into holes and they get connected. So that is how breadboard has made it easy for our prototyping. Prototyping is basically trying out stuff before you are committing to the circuit. Okay, once you are actually sure of the circuit, you use boards like either a perforated board that you can see the brown one in the top, sorry, bottom right corner, or you have something called a circuit board, printed circuit board that is in the green color. So these both are forms of actually permanently connecting the components together. That way you don't have them loose, and there is no risk of getting pulled out. So breadboard had that risk. In case you have connected something and your hand touches it and you pull it out and you don't know where to put it back, or you get confused, so the circuit will not work. But the soldered circuit boards are not like that. PCB stands for printed circuit board, and the other one is perf board, where you actually weld the contacts together, solder the contacts together, and that way it does not detach. So just quickly, so soldering is basically a pen kind of a thing, which heats up to around 200 to 400 degrees Celsius, and it melts a low melting point tin lead based alloy, which melts and connects your metal contacts together, similar to how welding works, but in a smaller scale. And so you can see this how it works. You touch the pen to the contact, it heats it up. You put that low melting point solder, it melts and fuses together. So that way you are forming permanent bonds with uh, whatever uh, whatever you want to connect, using either a PCB or this perf board. Okay, and yeah, so that was how you do the physical connections, the hardware electrical connection that typically happens in IoT. Okay, when you have to connect a sensor to a controller, or say actuator you want to connect. Okay, our power supply you want to connect. So typically done using breadboard or a circuit board. Okay, after that we'll just quick brief on how exactly you program and how the software side of things work. Okay, so starting with microcontrollers that we were talking about. So there is Arduino, there is ESP based ESP32, ESP8266, and then you have various other microcontrollers. Uh, so many of them currently support a programming language called MicroPython, which is basically Python made for microcontrollers. Okay, so it has a smaller bootloader, smaller compiler, and so Raspberry Pi Pico is one of the common boards that work on it. So you just write a Python code, and this board is going to execute it for you. And these gold pins that you see are where you connect your uh, other sensors, actuator, other components. Okay, uh, so that is MicroPython. And then when we come to Arduino, or actually, as far as microcontroller goes, any microcontroller supports C programming language, because the C and C++ language are very close to the hardware. So it is like I'm sure most of you know. So there is assembly language that we have. Assembly language is very low level and very difficult to do for a human, but it is very easy for a computer to understand. So C as a language is very close to assembly, very close to the hardware. So that way you don't have multiple layers of translation, and there is no confusion and all that happening in between. So C is one of the most popular language when it comes to Arduino, microcontroller, and things like Teensy, PIC microcontroller, STM32. And you can use it to program Raspberry Pi Pico also. And then coming to boards like single board computers, where we are talking about Raspberry Pi and other single board computers from Orange Pi, Banana Pi, and NVIDIA Jetson boards. Then we have Latte Panda boards, Asus Tinker board. So all these boards are full-fledged computers. They run some form of Linux operating system. So because it's a full operating system, you are able to install any language as such. And Python is one of the most common language that we use for programming for the physical computing aspect. So where you have to control sensors, actuators, LEDs, lights, motors, displays. So Python has become like the de facto for that. But of course, you can use Java also on boards like Raspberry. So Java is a quite an old object-oriented language. And then you have the typical web framework stack. You have HTML, JavaScript, and CSS. So you can use this to build web applications uh, for your whatever IoT device that you're using. But JavaScript as itself is also used in the form of Node.js to do hardware programming, similar to how we use Python for sensors, actuators, and stuff. And recently, we also are moving on to Rust as a language, quite easy to pick up language, they say. And then again, once you touch Linux, you are of course going to be. So this last logo stands for Bash scripting. So you must have seen this command prompt usually. Okay, whenever a typical movie hacker always has this black screen with green and white text moving through. So that is what in the Linux community is called as a shell script, or rather the shell environment. And so we do programming in shell as environment also, to do automations with regards to various applications and things pertaining to the Linux kernel itself. Okay, so that was just a simple introduction to the programming. Okay, and then specifically when you talk about IoT, you would want some form of mobile application generally. So Blink IoT is one of the most popular uh, mobile application develop. So it's a development tool actually. You are able to use the Blink application and build apps for your hardware. So let's say you have a uh, some Wi-Fi based device that controls a robot. Let's say you have four motors connected, and you have written a program to move the motors as per the necessary command. But you want to command that controller somehow. One simple way it can be, you have buttons on the robot itself, but then that is useless because we cannot keep going behind the robot. So that is where a mobile application can come into picture. So very quickly using drag and drop methods, using Blink, you are able to build mobile application for dashboards, controlling switches, and also visual based. If you have a camera, you can do that also. Okay, so that is the Blink IoT platform. Similarly, there's another platform called MIT App Inventor, which is another very easy, initially built by Google, but now handled by Massachusetts Institute of Technology. You can just click on Create Apps, sign into your Google account. So, any of you interested in simple Android application development can uh, start using this. Okay, so I'll just quick. Okay, so I just created a new project. You can see it shows how the user interface actually looks. So I can just drag and drop a button, image if I want, label. Okay, if I want to pick a date for something, or say I have a button for left, right. Say, let's say we are trying to do for a robot control. So I can have a. This is a learning in itself, but yeah, so we can basically put four buttons and make it do left, right, up, down. Okay, using the blocks panel over here. Okay, so simple. When button one dot click, send something using Bluetooth or Wi-Fi to whatever device you are connected. So that way you are able to control the Wi-Fi Bluetooth connected device, which is robot in our case. Very simple application. No coding required. Just drag and drop. Okay, so I encourage all of you to try MIT App Inventor. I'll just put up the link. Okay, you can try the MIT App Inventor. Easy to build Android applications. You can build any sort of Android application. It's not necessarily with respect to IoT, although usually it comes in the form of IoT control application. Okay, so yeah, so until here, any of you has have any doubt, or you have anything to add, anything to share? Okay, have you worked on any of this? You would like to share it with others? No. So- At least give me some answer. I hope you all have been able to hear me past 45 minutes. I, so no doubts. Okay. So okay. We want to know about Blink IoT. So uh, I can quickly go to the Blink platform. Okay. So Okay, so you can see I have not signed into Blink currently, so I will not go much into that. But it is basically similar to how I just showed MIT App Inventor. You drag and drop stuff, and you can configure things, and it has a mobile application where you can use it to you basically build an application, and then you use it to control whatever IoT components you have. Okay, it can be as simple as a robot or as complex as a smart farm, smart home, smart city, etc. Okay, so they claim it is a low code platform. So it's not no code as such, but it is very low on code, is what they say. But MIT App Inventor is basically no code. You do no typing at all. It is only drag and drop user interface, drag and drop the blocks for coding, and you have applications ready. Okay, so Blink is basically a tool to fast track your IoT application, because otherwise you will have to build applications from scratch. You have to build a website from scratch. Instead of that, you only focus on the electronic aspect and send data to the cloud, and then Blink does majority of the work for you. You only configure it how you want it to do it for you. Okay, so you can come to the documentation page. They have it all well explained. Okay, so I think otherwise we can move ahead. So one of the most popular and uh, interesting home automation and IoT platform called Home Assistant. So it is basically a open source tool. It is a piece of software that you can run on any computer. That can be a single board computer or a laptop, or some people have tried it on a mobile also. But basically, any computer capable of running Linux can run Home Assistant software, and it is like the central hub, like the brain of your home automation, smart home, and your IoT network, basically. Okay, so we can quickly go to. Okay, so open source home automation that puts local control and privacy first. So the most important use case for this is the privacy first and full local control. Okay, which basically means, so when we are talking about Apple HomeKit, okay, so you have your Apple Home, the smart speaker connects to your Apple devices and only works with devices that are Apple HomeKit compatible. Okay, similar you have Google Home, again a smart speaker, and then you have its related technologies. Only they work with it. Same thing with Alexa. Okay, Amazon's version of the same thing. So what happens is, whatever. So when you say, "Hey Alexa, turn on my light," "Hey Alexa, turn on my sprinkler," so what basically is happening? Your voice commands are going to Amazon servers. Amazon servers are trying to understand what you say, and then the signal is coming back to switch on the sprinkler. Please
बट
mute, na.
मेरे पास शायद एक होगा
Vineet,
देखूंगा देखो
Vineet,
నా దగ్గర
please
ఖాళీ
mute.
పడుతుంటాయి అది ఎత్తుకోవాలి ఇది సరే సరే
Vin-
టైప్ సి కదా టైప్ సి ఎదురా అదేది పోయిందా పోయిపోయిందా అదేరా
Vineet, can you please mute?
డైరెక్ట్ గా అది డైరెక్ట్ టైప్ సి కదా నా డాంగుల్ ఉంటే అవ్వదు అలాగా డైరెక్ట్ టైప్ సి నాకు లేదు
Vineet,
సాన్ లంచా అయ్యి వేరు కాదు రా రే నాకు ఇప్పుడు తేలాలరా రే కట్ చేయాలి
okay. Yeah, so we will okay, so yeah, so basically the point was that so we are all our signals and our voice and our control signatures all go to Amazon server, and Amazon server is basically able to track all that you are trying to do with your smart device. Okay, so that is where Home Assistant is standing out. It is basically on your computer in your home, and none of the control leaves your home. So no one else knows what you are doing with your home. That is what you want it. It is your home. It is your private space. You don't want some random server, some maybe even Chinese servers to know I'm trying to switch on my bedroom light now. I'm trying to lock my main door now. Okay, all that. Okay, so yeah, so that is Home Assistant. So they have a matching mobile application where you are able to build a IoT network for your home and then use your mobile application to control and literally almost anything, because it is such a huge community. Anything that can be made smart is able to be made connected to Home Assistant. That is how that is the level of connection that that is the level of connection that Home Assistant allows. Okay, so I will just go through a quick demo. So this is my real time smart home that I have deployed. I'm still it is in the it's a work in progress. It is not completely built out, but you can see certain things. So this is the home page. Okay, so here I can come and check what are the devices connected. MQTT is another protocol for communication. So whatever uses that protocol, I can see it under this, and anything that uses Bluetooth can will come under this. And yeah, so there are other things that we can. So there is one popular China-based company that makes smart plug. So all those make smart devices in general. So those devices come under this device called TUIA. Okay, so these are some devices that we have. So I'll quickly go back to the home page. So this is what we call the dashboard. Okay, so I have my CCTV also locally connected to Home Assistant. So you can just quickly go. So this is the a single camera that is currently there recording the back of my home. Okay, you can see it's quite dark. It's all real time, 7:15. Okay, and so we can see currently it says motion is detected in that camera, and then there are 5 objects detected. So what are the 5 objects we can? So Home Assistant, the as a tool, is able to detect multiple things. So you can see there are at least 5 people here. Okay, there are actually 7 people, but it is detecting 5 people. In We are able to see that variable value, and then the last motion detected we are also able to see. So these are basically some smart functions that I have added. Okay, I have another smart hub connected to my aquarium. So I have an aquarium in the living room. So you can see the aquarium is currently consuming 40 watts of power, and the aquarium temperature is currently 29.1. So these are all real sensors that I have connected to my aquarium, connected over Wi-Fi to the Home Assistant instance running on a single board computer called Raspberry Pi. Okay, so this is a single board computer. So this is running the Home Assistant that you are seeing here, and another small device called. So this is the ESP based microcontroller. This is an even smaller board. So to this board, I have connected 2 sensors to detect temperature and current consumption. So so the aquarium hub is on this particular ESP microcontroller, and the entire Home Assistant instance is on this Raspberry board. And then we are also tracking our home power consumption. You can see currently I'm consuming 700 watts between lights, fans, and the PC that I'm sitting on. and outdoor lights that we have on and all that. And there is another smart plug that you're able to see. So this is the back floodlight. Okay, so I'll quickly open up Frigate. Okay, so you can see I just opened the same thing so that you're able to see in real time. So I have a smart switch connected to a floodlight. So as I turn it on, just give me 1 minute. So, as I told, this is still a work in progress. So there has been a bit of up and down that we had to work. Okay, yeah. Okay, so coming back, so you can see as I turn it on, the CCTV, we are able to see the light just turned on. Okay, so it is automatically connected and automatically switching on, switching off, and I can do that from my mobile application or uh, web application. So this is all real time, and we use it in real life. Okay, because the power switch for that light is actually in the first floor. So instead of actually going up and down every time we have to switch on, I have connected to the home assistant and using our mobile application. So later down the line, I am able to connect microphones and speakers and have a similar to Alexa experience. I can just say similar to Alexa some word. Okay, hey home, switch on the top light, and it's going to do it in the background for me. So that is the power of home assistant. Okay, so you can see again CCTV is integrated using a tool called Frigate. So Frigate is a separate tool that exists. You can install it separately, but I have installed it as part of Home Assistant to take care of my CCTV requirements. Currently, there is one camera. You can add any number of cameras as long as the whatever computer runs Home Assistant has computing power. Okay, you can also do energy monitoring. Okay, so you can see from the grid I am consuming electricity now. In case I have solar, in case I have a battery backup, I have a generator, I can connect all of them here and measure how much electricity am I using, how much electricity am I storing, all that interesting metrics. Okay, so yeah, so that's a basic quick overview to uh, Home Assistant. Anyone have any doubt with regards to Home Assistant? Okay, so I have a quick demo to show. I will quickly. I just want to show how easy it is to use Home Assistant and build smart devices. Okay, yeah. So I hope you're able to. Yeah. So I hope you're able to see me. I have this small, the same ESP um, board that I was showing you, and I'll just show you how easy. I'm just connecting it to a USB cable connected to the same PC. Okay, and on a tool called web.esphome.io, I just go to connect, select that particular port, and say prepare for first time use. Okay, so I will have it in front of you. You can see there is no not much. I have an LED light connected just to have one smart thing to use. Okay, so my plan is to build a smart switch so that I can turn and on and off this light using the Home Assistant interface. So just a simple LED light. So this is installing the initial firmware, and then I can because this is a Wi-Fi connected device, I have to enter my Wi-Fi password. Okay, and then I'll say connect. So that way, this the board that I'm carrying in my hand will get connected to Wi-Fi, and by that I am able to. So immediately it says new device discovered. Okay, so instead of doing it here, first I will go to a tool called ESP Home Builder. Okay, so this is the new device that just got discovered. So I'll say take control because I want Home Assistant to control this device. Okay, so here the programming is basically through a scripting language, a markup language called YAML. It is a shorthand for yet another markup language. YAML is what they call it. So I have a sample YAML file here. I will copy it. I will paste it here. Okay, not much to it. So there is some Wi-Fi details and API details. And the main thing is here, there is a switch. I'm saying I want it to be a switch on the pin called D4 on this particular board. And I call it LED1. Okay, that is all. And then I will say install it wirelessly onto the board. Okay, it will take some time. Okay, so that is done. So the installation is done. It will take some time to restart. Now it says offline. It will come back to online in some time. Okay, once that is done, I can add the device into Home Assistant as any other device. So you can add your smart lights, smart bulbs, all those things. So this is one device that I just added. Okay, and yeah, so this is the device that I was just showing. So LED1, remember we called it LED1. So you can see that one here. And here is a switch. I can just use it to switch on, switch off. So that is how simple it was to perform smart uh, connecting smart devices, building smart devices using boards like the ESP based Wi-Fi board. Okay, so it is not necessary you have to build devices like this. You can buy ready-made. So there are ready-made smart plugs like this. You can just buy it, connect it with your Home Assistant instance, and start being able to connect it, control it. In case you wanted to build, this is how simple it is. Okay, so I just showed you all in front of you. Within 5 or so minutes, I was having a smart device able to be controlled with the Raspberry Pi. Okay, if you want to add it to the dashboard, you can come back here, say add card by entity, and search for LED. Okay, and when you say done, we again have the same thing on our dashboard: on, off, on, off. So that's how simple it is. There is also, I was talking about the mobile application. I'll quickly show you that also. So this is again the mobile application that we have. Okay, we have this switch here, same mobile application based control. So this is also how easy it is to incorporate IoT into your smart home specifically. Do you have any high level documentation? So for me, as my smart home, I have not yet done it. As I said, it is still a work in progress. So the documentation part is still yet to be done. So I was still just trying out stuff, connecting stuff, see how it works. And this is the state I have left it in for some time to check. Okay, you can see the power just went up. So my parents just switched on the AC. So now it was 700 watts. So now it is 2000 watts. Okay, so yeah, so that is the Home Assistant. Okay, so that so anyone again, you have any doubts with what I have demoed just now? Okay. Okay, so we'll move on to the final leg of the session. So we have basically where when you want to start learning, what should be your uh, path of learning? Okay, what I generally suggest is start with simulation and online based tools such that you don't have to buy the physical stuff. Okay, so simple things. I was just showing you about the Tinkercad. Just select all, delete, bring back a breadboard, and bring back a Arduino Uno. So this is the microcontroller that we have been talking about, quite popular. And I will connect, yeah, I'll connect a simple LED with a resistor. Okay, I'll connect it to pin number 13, and the negative I will connect it to ground. Okay, so this is a simple circuit for blinking an LED. I'll click on code here, and you can see there's already a predefined. Uh, so it is going to be a hello world example. Okay, those of you who are already done programming, you know what is hello world. It is like the basic uh, to see all your pipeline of programming is working. So in the microcontroller world, the hello world is going to be LED blink to make sure your circuitry works fine, power works fine, the programming is working fine, things like that. So we have a simple example here. We don't even have to do anything. I will just start simulation, and you can see the LED turning on and off. So it is basically simulating the electronic circuit. Okay, I quickly I will show you another simple example. Okay, I will add. I have a servo. Servo motor is basically a motor that uses angle as a form of movement. So, so a regular motor keeps turning. Servo motor turns to a particular direction and stops. So I will connect grounds together. Ground is basically the negative. I'll connect the positives also together. Okay, so the wiring can be a bit confusing. I'll try to make it. Yeah, so I just rotated it such that the wires are cleanly visible. Okay, I can also change the color, I suppose. So red wire, black for negative. Okay, and then you have one signal wire for your servo, which is your output. I connected to pin number 6, and one signal wire for your sensor. I'll connect it to pin number 8. I'll make the signal green and the servo motor yellow. Okay, so you can see the wiring is quite simple. It is hazardous for now, but easy enough to understand. Okay, so I will delete these blocks. So this is a visual tool Tinkercad allows us to use. If you want, you can use the code editor. Okay, you can actually type the code, but I would suggest you start with blocks. Okay, so I can say input read ultrasonic distance sensor, and so I what we will do is we will not couple them together. We will just randomly rotate the servo just to show how the thing works. Okay. Yeah. Okay. So I'm going to rotate. So I hope you're able to read the text here. I'll just zoom it a bit if you need it. Okay, rotate servo pin on pin number. So we have connected the servo yellow wire to pin 5. Sorry, 6. So I will connect that pin 6 both places and say go to 90 degrees, then go to 180 degrees. Okay, so it's going to wait for 1 second, go to 90 degree, wait for 1 second, go to 180 degree, wait for 1 second, and repeat because it is in a forever block. Okay, and you also want to read the sensor value. So I will say print to serial monitor. What do I want to print? I want to print ultrasonic distance sensor on pin number 8. So it is on pin number 8. So that's what I will say. And in centimeter units. So that's our simple code, which is basically turning our servo and reading sensor value. So I'll say start simulation. Okay, so you can see, you are able to see the servo is turning, and when you click on the sensor you are able to change. So this is basically a distance sensor. So because I cannot actually put my hand in front of the screen and measure distance, we have a digital version where this blue dot is supposed to be my hand, which is an obstacle. I can move it and it will show me the distance. I can open, yeah, serial monitor. So when I open serial monitor, you can see when I bring it close, you'll see 47 centimeters, 46 centimeters is the distance. When I take it far away, it is going to be 280 centimeters. So this is basically measuring distance. So that is how simple it is. You try out stuff on Tinkercad. So I will put up this link also, tinkercad.com. Okay, so this is a simple project. So what you can, as a one step ahead, do is change the angle of the servo depending on how far the obstacle is. Okay, so now there are two different things. The servo is doing its own thing. The sensor is doing its own thing. Instead of that, you can couple them together in your code. I'll not do that now because it is again it takes some more time. Okay, so yeah, so that was Tinkercad. Similarly, you have other tools. So specifically, when you want to work on IoT, you can use a tool called Workme. So you have multiple boards that you can simulate. Arduino Uno that we just did, ESP32 based boards, Raspberry Pi Pico boards, and STM32. So these are all four different microcontrollers that we were talking about. Okay, so there is already simple projects that are already existing. Okay, so you can see there is a code here. You can type the code, you can make the circuit here and simulate. Okay, maybe if I sign in and check, we can do whatever, but I'll not simulate it for now. But you can see this is one of the predefined projects already there, so you can make similar such projects. Okay, once you sign in, you will get an option to create a new project. Okay, and then there are more advanced tools like Simulink and Proteus, which are, as you can see in the bottom screenshot, these are, uh, so the right side image is from Proteus, and so these are basically advanced simulation software. So Simulink specifically simulates a lot of things. We can use it to simulate your electronic components and displays, controllers, along with coding and all that. But you are also able to do hydrodynamic testing, load testing, simulating physics and all that. Okay, and then coming to, we have a uh, what is a specialized tool for circuit design called KiCad and Altium Designer. So KiCad is free and open source, Altium is paid. Both of them are very good, very feature rich. So I can quickly open one of my previous KiCad projects. So I have been uh, building yeah, just give me 1 minute. Yeah, I'll quickly switch on my camera. Yeah, so this is one of the circuit I was designing for some product that I was building. Okay, so this is a circuit design with all the capacitor and all those individual components, and this is how the physical circuit looks, and this is how it comes after it gets printed. So this was fabricated by one of the companies based in Bangalore. So I built this circuit board and then soldered the components onto this, and I use this to. So this is a Raspberry Pi board. So this sits on a Raspberry board like so. Okay, so it sits on a Raspberry board like so and enhances the functionality. So that was a product. Okay, so basically you design your schematic. This is what is called a schematic design, and then you build a circuit board in your CAD software, get it printed. It is going to come to you in the form of uh, circuit boards, PCB, printed circuit board, and then you add your components. So these both are basically the same thing. So one of them has components and one of them is empty. Okay, so yeah, so that is just simple example of designing circuits and working with IoT. Okay, so yeah, yeah. Anyone has doubt? I think we are close to the end of the session. You can ask me doubts you have, and okay, I think I'll just share link of our yantras to join the yantra society. Okay, yeah, I'll just share it in some time. So those of you who are not yet part of yantra society, do join. uh, so there are many people who are very eager to share knowledge with all of you who want to learn. Okay, I myself will be there, and so anything if you want to build projects, you want to learn, you have doubt in whatever you are building, so we'll be there to clarify it for you. Okay, yeah, so in case you have any doubts, please put it forward. In case you want to add on anything. So the content has been heavy, I can understand. Maybe so much of it has gone above your head. But in case there's anything specific that you want to learn, please reach out to me. Okay, so that's my roll number, first batch, 2021, first term. Yeah, I'll be okay. Just give me 1 minute. Okay, yeah. So you can reach out to me either on my personal email or the student email that we have there. Okay, the domain is the same. That roll number at ds.study.iitm.ac.in. Okay, so those of you who want the link, just wait for some time. I'm asking and getting it to you. Okay, otherwise, while we wait for that, thank you all for being here and hope you had a nice time and hope you learned something new. Okay, so with that, we'll come to the end of our IoT series summer camp sessions, and we are planning for more sessions along the way. And in case you have specific project that you want to do, or you want to learn specific parts of the entire process, not so there are some people who might only be interested in the networking aspect, the programming aspect, or only the physical sensor aspect. So you can learn any specific part. We are here to help you. Okay, yeah. So thank you so much for being here with us. Yeah. So Vivek, do you have the link to join the society? We have some. He has some. Okay, I think I found one. Uh, yeah. So I put it up in the main group. Just check.